Hello guys, welcome to the video. So in this one, I want to show you how to improve rotation of the agent so it looks a bit better than just what we have right now. Because as of now, it really looks weird when it tries to rotate towards the target. It sort of goes like around the, like around the target and not facing really the direction it is moving to. And that's what I want to fix. Let me delete these two extra enemies. For now, we can just test it on one. And then let's go to the enemy script. And first, in the awake, I want to disable the default rotation from agent, because otherwise it can interrupt with the rotation we're going to set. I'm going to do agent update rotation equals to false, just like that. Now let's save it and let's go and see what we have as a result. Now enemy moves without any rotation. Perfect. The next step would be to apply a custom rotation that we're going to create. I want to make a method, private void face target. Now in this method, we need to know what is the target, where we're supposed to rotate. For that, we can pass a variable into the method through parentheses. We just need to make a variable over here, and as example, I'm gonna make vector3 new target. So now this method can accept, actually must accept, the variable when it is called. If you try to type here face target, you're gonna see it is underlined and it shows you an error that says it doesn't have an argument passed into parentheses. So now we can call this method and we can give it a target inside of this method. And that's what we're going to do. But first, let's finish the method. The simplest way to do that rotation would be by changing transform forward of the enemy. And that's what I want to do for now, just to show you how it can work. And if you like that option, you keep it, okay? So each transform has a forward vector, which is represented by this blue arrow over here. And you can change it, you can give it a value and it will become that value. So we can go back to the script. And over here, I can do transform forward equals to, and we cannot just pass it a new target. That would not work very well because we need to get direction to that position, to the new target. To get a direction, you usually have one vector and then second vector, and you subtracting one vector from another to get direction between these 2 points. So that's what we need to do. We need to do new target minus transform position. And now we'll get a direction that this enemy is supposed to be facing. Let's save this, then let's go to the update. And over here, before we update the waypoints, we're gonna call face target. And inside of this face target, we need to pass next point of the movement of this agent. Luckily for us, it is very easy to get. Now we can just type agent steering target. And this will give us a next movement point for this agent. When agent is moving, let's hit the play button and then pause button immediately. We can see these points over here, these sort of nodes. If you don't see them, you can enable them over here by clicking Show Path Query Nodes. So as you can see, this path has nodes over here, right? It has sort of a points of kind of like intersection where enemy changes the direction. And we can get vector3 of this point by typing steering target. So we pass in this value into the face target method over here, then we use it to get the direction, and then we make it transform forward equals to that direction. And thanks to that, now when you make enemy move, it's gonna be facing the way it is going. It's gonna feel really fast and really nice. And if you like it that way, then keep it. Look at this, right? However, I feel like it's a bit snappy and could be smoother and nicer. And that's what I want to show you, how to make this rotation smooth. It may be a little bit confusing, especially if you're just starting out, but I'll try to explain everything that we need to know for this, okay? So first, to have a smooth and slow rotation, we need to know how fast this enemy should rotate. So let's go over here and let's make a serialized field, private float, turn speed. And let's make it equals to 10 by default. I think it's going to be a good value. Actually, I know this is going to be a good value because I have a prototype, but that's a secret. Don't tell anyone. Now, we're going to go down to the method we had, face target over here. And you already know that we can take transform forward and making it look into the direction of a target. Now what we're gonna do is something different. It may be a little bit confusing, especially if you are a beginner and you just start doing Unity, but I'll try to explain as much as I can, alright? And if it doesn't make much sense, just stick with it, and with experience, understanding will come to you. It's just like using your phone or computer. For example, me, I have zero idea how my phone works, but I know how to use it. So it's kind of a similar situation here, but I'll try to explain as much as I can, alright? And also, even though it might look a bit complicated, this is the easiest way to do this. So there is no really a simpler way to rotate objects slowly. So let's go to Unity real quick. We have an enemy over here, and this is the vertical rotation that makes enemy sort of tilted into one or another direction, and this is a horizontal rotation, and our goal is to rotate enemy horizontally only. To do that, we can go to the script and we can get direction to target first. For that, we're gonna do vector 3 direction to target equals to new target minus transform position. So it's similar to what we had before, but this time we store it in a local variable. And let me leave a comment here just for easier understanding. Then what we want to do is to remove the vertical component from this direction. If we remove it, then rotation will not be applied vertically. Rotation will be applied only horizontally. And thanks to that, we'll just make enemy face the target. So to remove the vertical component, we just need to type direction to target dot y equals to 0. Essentially, this one will ignore any difference in the vertical position. Now that we did remove vertical component from this direction, we only have to rotate the object, and it will be rotated horizontally. So how are we gonna rotate the object? First, we want to get the rotation. To get the rotation, we simply need to type quaternion, and quaternion basically means rotation. We're gonna name it as new rotation, and we're gonna make it equals to quaternion look rotation on direction to target. If you've never seen look rotation before, you can put your mouse over it and you can see it says creates a rotation with the specified forward and upwards directions. And because we're ignoring the Y, this will rotate object only left or right. It will not do any tilt up or down, and it will perfectly align it with the horizontal plane. Now let's go forward. And let's take transform rotation and change it according to the target rotation we have. Now here, we need to type something else that also may be confusing for beginners, but I'll try to explain it, okay? And also I'm gonna attach a video to this lecture that explains it very well, so if you want to widen your understanding of it, you can just check out that video. You're gonna type quaternion.lerp, and lerp allows you to change value from point A to point B smoothly. It will allow us to do something with the time. Let me quickly explain what the lerp does. So let's say we have point A and point B, and there is a path from point A to point B, right? And when you get in a lerp value, you need to know the percentage of that value, or you could call it a step value, or you could just call it a t. So let's say my step is 0.5, which is half of the value. So when you do that, then lerp will be equals to half of the value between A and B. Then, because we're doing it in the update, next time we're gonna call it, the point A will be here now, and we're gonna get half of the value. Then next time we're gonna call this method, and next time we're gonna try to get the lerp, it's gonna be like that. This will be half of the value, and so on, and so on, and so on, and so on. And because of that, it's gonna do smooth transition from one value to another, because we get in half of the way every time we try to get the lerp. I hope that makes sense. Now, what we're doing here, we're doing quaternion.lerp from transform rotation, so from the current rotation that we have, to a new rotation. that we want to have. And then we're gonna do turn speed multiplied by time.delta time. And here again comes something difficult, time.delta time. Every time it will come up, I'll explain what it does. As of now, I don't want to overload this video with information because we already did learn lots of new things and it can be pretty confusing. You just need to understand and remember that time.delta time is used when you want to make something frame rate independent, because some computers are slower and they have lower frame rate per second, some are faster, and even same machine can run game differently. It always depends on what is happening in the background. So sometimes you can have 60 FPS, sometimes you have 37 FPS, for example. And if you don't want to have any difference in calculation, you can just multiply value by time.delta time, and that will even it out. Technically, time.delta time returns interval in seconds from the last frame to the current one. And if your FPS is low, then this value will be bigger. If your FPS is high, then this value will be lower. And this value will be always adjusted according to the frame rate on the machine. That's why it helps us to even out any calculations we want to do and make it frame rate independent. We can quickly debug it so you can see what the value is. I'm gonna do debug log time.delta time. Now I'm gonna show the console to you just so you can see the value, and you can see how small it is because how fast my frame rate is. And now I'm taking this value and I'm multiplying it by the turn speed. And as a result, I'm getting a really small value. As quick example, I'll take one of them. I'm gonna do 0.01135574 and my turn speed is 10. So it's multiplied by 10 equals to something like this. So now this is my t for my lerp, and this is a really small value. It's basically a 0.1. Using it for the rotation gives me somewhat of this smooth step every time I'm calling the method, which, as you can see, turns it into a really smooth change of value, because we get in 0.1 from A to B. Then next time A is here and I'm getting 0.1 from A to B, and next time A is here and I'm getting 0.1 again. So basically it makes it smooth and changes it with the time. Nice. Now I'm gonna remove this. And again, if that sounds confusing, you just need to know that you want to make something frame rate independent, you multiply it by time.delta time. And with experience, you'll definitely learn how to use it. All right, our method is done. I'll just put a couple of comments on the top so you can easily remember what it does. All right, so method is finished. Let's save it. And let's go back to Unity and let's try this out, okay? We're gonna go back. It's gonna compile it. Now we're gonna go to play mode and see rotation of this enemy. Let's go. Yay, nice. Yay, nice. Nice, smooth rotation that doesn't feel glitchy, just feels like he's rotating really fast to the place he needs to go. All right. I think we can use it. We should use it. I like how it works. And this is probably it for this video. Thank you for paying attention, and I'll see you in the next one.